Hello and welcome to Morehouse's Math Menagerie. Today we're going to be talking about inference for two variances. When we are comparing two variances, the hypotheses are always the same. The null hypothesis is that the two variances are equal, and the alternative is that they are not equal to. In this class, the alternative will always be that the two variances are not equal to each other. We are not going to look at situations where we say that the first variance is greater than or less than the second variance. We're only going to focus on a not equals to alternative hypothesis. You will recall from the previous chapters that when we dealt with variance in the past, we use a chi-square test statistic. Here, when we deal with two variances, chi-squared doesn't work anymore, and we actually move into what's called an F-test statistic. Here is a graph that shows several F curves. F has two different degrees of freedom, which we'll discuss more in just a second. The higher the degrees of freedom, the less skewed it becomes. So you can see the red graph here, when the degrees of freedom are both 1, it is very, very heavily skewed to the right. As the degrees of freedom increase, like the blue graph, and then the brown graph here, it becomes a little bit less skewed. Here is the equation for the F-test statistic. It is the sample variance of one sample divided by the sample variance of the second sample. It's really important here that when you are using the F-test statistic, that the variance that goes on the top in the numerator of the fraction is always the larger of the two variances. Here, it doesn't matter which one's sample 1 and sample 2. It just matters that the larger variance goes in the numerator and the smaller variance goes in the denominator. As I mentioned on the previous slide, there are 2 degrees of freedom, one for the numerator and one for the denominator. They are still calculated by finding 1 minus the sample size for each of the 2 samples. But we have to remember that there are 2 separate degrees of freedom for the F statistic. The conditions for this test, again, we have random sampling. It's very important that both samples are independent from each other and that both populations are normally distributed. Similar to the tests for one standard deviation or one variance, when we're testing two variances, it is very important that both populations be normally distributed. In this class, we are only going to do hypothesis tests on two variances. We are not going to do confidence intervals. So I want to go ahead and jump to StatCrunch to show you a few examples. But before I do so, I thought I'd show you this lovely picture of some rainbow bagels I made a few years ago. They look really nice, but they didn't taste very good. In StatCrunch, I just want to go over two separate examples. Let's start with number 2 in the homework. Researchers measured skulls from different time periods in an attempt to determine whether interbreeding of cultures occurred. Results are given below. Assume that both samples are independent random samples from populations having normal distributions. Use a 0.05 significance level to test the claim that the variation of maximal skull breadths in 4000 BC is the same as the variation in AD 150. You can see here we have a table with all of our data in it, and the first thing they ask us is to define the null and alternative hypotheses. This is pretty straightforward because in this class, we are only ever doing a equals to for the null and a not equals to for the alternative. We're never going to deal with any of these less than or greater than alternatives in this class. So let's check that answer. Okay. Now it asks for the F-test statistics. So we're going to go over here to StatCrunch. Let's shrink this down a little bit so we can still see the problem. We're going to go stat, and we'll go down to variances, and now we have 2 sample, and we have with summary. We don't have the data, we have with the summary. Pull that up, and it gives me this table. Notice that it doesn't ask for standard deviation. The problem gave us sample standard deviations, but StatCrunch is asking us for sample variance. So make sure you square these standard deviations before you put them in here to make it variance. We also need to make sure that the first sample is the larger of the two. So here, I'm going to make the first sample AD 150 because it's going to have the larger value. And remember, the first sample is always the one that has the larger variance. So I'm going to in my calculator square 5.33, and I get 28.4089. The sample size here was 30, so I can go ahead and type in 30 for the sample size. For my second variance, I'm going to square 5.14, and I get 26.4196. Again, the sample size was 30. For the hypotheses here, if they're equal, we said they were equal here, then that means the fraction should equal 1. If they're not equal to, that means the fraction should not equals 1. So we're going to leave all this alone. This is already set up for us. We're going to hit compute, and we get this really nice output. F-stat is 1.07, 2 decimal places. I think it's going to round to 1.08 actually is what we're going to round that to. All right. And then our p-value was 0.846. 0.846. Our answer. All right. Now for our conclusion, you'll notice that our p-value is quite large. It's much larger than the 5% significance level. So we're going to fail to reject. So only A and D are possible options here. So let's read through them together. A, fail to reject the null. There is insufficient evidence to warrant rejection of the claim that the variation of maximal skull breadths in 4000 BC is the same as the variation in AD 150. That sounds pretty good. That's going to be what we select there. When we fail to reject, that means there is insufficient evidence to reject the null hypothesis, and that's what they're saying here with these words. Let's go ahead and check that. All right. Next, I want to jump up to number 7. Number 7 says, listed below are time intervals in minutes between eruptions of a geyser. The recent times are within the past few years, and the past times are from 1995. Does it appear that the variation of times between eruptions has changed? Use a 0.05 significance level. Assume that the two populations are normally distributed. So let's look at our table of our data here. Here's the recent eruption times, and here's the past eruption times. I'm going to go ahead and open that up in StatCrunch just to get that ready for us. The first thing we're asked to do is to define the null and alternative hypothesis. Again, the null has to be an equal to, and the alternative has to be a not equal to. So here we're going to select C. Check that answer. That's really good. Right now it asks for the test statistic. So I'm going to go to the data that I opened up in StatCrunch. I'm going to say stat, variances, to sample, but here I have the data. So I'm going to say with data. On the previous problem, we had to be careful which one was sample 1 and which one was sample 2 because sample 1 needs to have the larger variance. When they give you the data, the computer's going to go ahead and figure out which one's larger and put it on top automatically for you. So we can just indicate that sample 1 is recent and sample 2 is past. Again, we're going to leave our hypotheses alone. We're going to hit compute, and we get these lovely f-stat and p-value here. So 2 decimal places, we're going to have 2.17 here for our f. Our p-value here is 0.215. Now for the conclusion, our p-value again is much higher than our 5% significance level, so we're going to fail to reject. So only B and C are options. Let's read through B first. Fail to reject the null hypothesis. There is insufficient evidence to support the claim that the variation of times between eruptions has changed. That is what we're looking for here. We were trying to find evidence for this alternative that the variances were different. We did not find that. So B is going to be our answer. Let's check that. Awesome. Okay, today's video is pretty short, just those 2 examples. Remember, please utilize this Ask My Instructor button if you have questions. Thank you for joining us. Have a great day.